I'm so pleased to pass it over to our presenter today, Phil Comeau. Phil is an emeritus professor with the Department of Renewable Resources at the University of Alberta. Phil taught silviculture at the U of A for 20 years until retiring in 2020. During his career, Phil has conducted research in silviculture and forest ecology in BC and Alberta with a recent focus on silviculture options for boreal mixedwood stands and effects of vegetation management practices on plant community diversity and stand composition. Phil continues to be actively involved in the development and refinement of the mixedwood growth model and its applications in support of management decisions. So with that, I will pass it over to you, Phil.
Okay. Thank you, Rachel. I'll just have to share my screen here. Let's see. Let's try that one. Oh no. Oh, okay. Okay. Hopefully everybody can see that now. I believe if the screen is too small on your computer screen, that you can use the Zoom button to enlarge it. Hopefully. So my apologies if it's small. I think it's the difference between my setup and everybody else's possibly. Yeah. So yeah, despite retiring 6 years ago, I still keep involved and still keep active. I've been busy trying to write up results from several studies and gradually getting stuff written up and finished. And the Judy Creek experiment is being passed along to Brad Pino at the University of Alberta. So he'll be continuing on, hopefully with work there in collaboration with Michael Hupting with the CFS out of Sault Ste. Marie. So today it's my pleasure to update you guys on age 20 results from Judy Creek. So I titled the presentation Spot Treatments for Regenerating Mixedwoods, age 20 results from the Judy Creek Mixedwood Experiment. So I'll talk about some of the things we've seen over time, because there is some history, some things that happened in earlier years that have had influences on the age 20 results. So we'll have to look a little bit at that. So first off, to begin with, those of you who've heard me rant about this may be a little tired of it. I see there's a few of you in the audience. Those of you who don't, well, this is a review, and for everybody, this is a review. So why mixedwoods? Well, they're pretty common in northern Alberta. Through the western boreal forest. They're very common, particularly in the boreal plains. So Manitoba, Saskatchewan, Alberta, and northeastern BC. So mixedwoods extend into the foothills and into the BC interior as well. So I'm talking primarily about mixtures of aspen and white spruce here. Though we got mixtures, we run into a number of other broadleaf species like balsam poplar or black cottonwood, paper birch, and we can have other conifers like black spruce, lodgepole pine, or jack pine occurring in mixtures. But the most common and widespread one is the aspen spruce mixture, which we think occurs because aspen is a fast grower. It's shade intolerant, so it needs to have its leaves in the sun. Spruce is a slower growing tree. It's moderately shade tolerant, so we can handle the low light levels underneath aspen for most of its life. So we get these mixtures that develop and that have developed historically across the boreal forest. So the importance of these, well, they have higher biodiversity than monocultures of either aspen or spruce, and they're important habitat. We find that overtopping aspen, and we'll see this at Judy Creek in a minute, can be beneficial to small spruce by reducing frost injury when they're small, by reducing weevil injury, and by suppressing one of the major competitors that spruce faces next to aspen, which is blue joint reedgrass, or Calamagrostis canadensis. Mixedwoods can also give higher total yield and potentially higher long-term productivity and resilience than monoculture. So by virtue of mixing a shade-tolerant spruce with an intolerant aspen, we get we can see a bump in total stand growth. And by mixing the aspen leaf litter with the spruce litter, we seem to have some increased nitrogen availability, increase in soil nitrogen availability, and increase in productivity. And we're also finding that mixtures may improve the resilience of forests to climate change, and drought and other factors. But at the same time, overtopping aspen reduces the growth and survival of spruce. And studies like the West Bogey long-term study, the Dade Mixedwood Experiment have shown that reducing aspen densities can increase survival and growth of spruce. So against this, what do we do? Do we just leave them, or do we tend them with thinnings or other things? So casting around, over my career, I've tried many different ways of trying to grow mixtures. Back in the early 2000s, Doug Pitt and Milo approached the rest of us with an idea that maybe we could do this using spot treatments of some sort instead of thinning an entire stand, or doing things at the stand level. So digging back through the literature, there was a paper back in 1966 by Jock Lees, working for the Canadian Forest Service at the time, who showed good response to spruce 10 years after spot treatments. And in fact, part of that experiment still exists out near Fawcett Lake, just beside the campground, which if you have someone who knows where it is, they can show it to you. He didn't have fancy herbicides. He treated cut stumps with borax, which is effective for controlling, but borax isn't really a good thing to use. It's quite toxic, but it worked. So he showed you could treat a small spot and release the spruce. So how big an area you could treat? He tried a number of different areas, so that's kind of hard to figure out how that works, because it's quite a complicated setup. We decided at Judy Creek to plant a moderate density of spruce, 400 stems per hectare, and then to treat, and we doing a bit of math, we figured out that if we treated 2-meter radius spots, that we would effectively be treating about 50% of the ground, and we'd leave about 50% of the ground, but potentially for the aspen, or early on. So recognizing over time, aspen canopies grow into the spots, but there's also some holes in the aspen, some gaps in the aspen early on. So here's a 2-meter radius spot. I don't think, oh yeah, there is a little spruce in there. Okay, so just after planting. Okay, so roughly 2-meter radius, and you see another 2-meter radius spot there, and there. So we have 400 spruce planted here, and then a bunch of 2-meter radius treated spots. Okay, so our research questions were, can we effectively regenerate mixedwood stands using spot treatments? How much vegetation control is necessary to get decent response in these spot treatments? Do we need to control all the vegetation, or can we get away with controlling only the woody vegetation and spots? How long do we need to treat the spots? Question 3. If we treat for 4 years, if we give 4 years of complete control, is that better than 2? And do spot treatments give us similar response to broadcast treatment? So how does treating spots compare to treating an entire block? So here, another spot treatment. This one was actually woody control. I won't show it again, but you see the a fair amount of grass that we have there. So the woody control was not targeting the grass in this case, so we got good grass response. Yeah, so broadcast or spot treatments similar in effect to broadcast herbicide treatments. And finally, if can we increase yield or shorten rotations by applying spot treatments and following them up with thinnings? The study was established in the Blue Ridge FMA on a site northeast of Whitecourt in the Swan Hills, just up there. The block was logged and in 2002, early in 2002, and treatments were initiated that year. So triclopyr was applied pre-planting, and the first of the glyphosate herbicide treatments in the spots were applied in 2002, and then the spruce were planted in 2003. The project team, I already mentioned Doug. So Doug was the project lead, and he really was the one who initiated this in collaboration with Milo Mihailovic. With IF Tech at the time. Dan McIsaac, and Dan McIsaac and I both collaborated on the project development. Michael Huptang joined the team partway through the project. I think it was around 2007 or so. And Susan Humphreys worked with me for many years managing the project. Let's see, the only one still in his job is Michael Huptang. The rest of us have sort of retired. And I also would like to recognize the contributions of many people who helped out in various ways and means of the study, including just overall support, getting it done, finding the site, helping with field work, and such. So lots of people have been involved over time, and there'll be probably more as we go forward. The project started with 8 core treatments. So BA, there was no spruce planted. That was broadcast aspen. So you know what the acronym means. BC was a broadcast complete control. So glyphosate applied in the full treatment plot. Okay, spruce planted at 1,600 stems per hectare. Broadcast herbaceous control, broadcast control of understory herbaceous, so the aspen was left standing to the extent possible. We had 1,600 spruce planted in that. So we'll see a picture of that shortly. Broadcast untreated, BN. Broadcast non-treated with 1,600 stems per hectare. So this is just spruce planted with the aspen left untreated. Broadcast woody control, a contrast to the broadcast complete control. So broadcast pre-planting triclopyr application that was intended to provide control of the woody vegetation and leave the herbaceous alone. Okay. Then 3 spot treatments originally. The radial control 2 years, so spot control, complete control for 2 years. Okay, so radial complete 4, radial complete 2, then radial complete for 4 years, and radial or spot woody control. So the radial complete were done with glyphosate. The 2 years was treated in 2002 and 3. The 4 years was treated in 2002, 3, 4, and 5. Okay, and the woody involved a triclopyr application pre-planting in 2002. Okay, and not followed up. The broadcast, should mention, the broadcast complete control had repeated herbicide treatments for 8 years. It was retreated in an attempt to provide complete removal of non-spruce vegetation. Okay. And the herbaceous control started out with the glyphosate application in the first year and second year, but then went to manual treatments for about 3 years because we found that the glyphosate was getting on the aspen leaves when the aspen were small. So we wanted to wait a few years. So manual pulling the understory herbaceous, and then followed up from about age 5 onwards with periodic understory application of glyphosate. Okay, so then at year 10, thinning treatments were added to the spot treatment. So there was an unthinned, so just the spot treatment itself, thinning to 800 stems per hectare, a thinning to 1,200, and a thinning to 2,000. So that was done for the 2-meter radius spots with 2 years of treatment. The 2-meter radius spots with 4 years of treatment, and the 2-meter radius spot woody control treatment. So we've got we added three thinnings on top of the unthinned in each. So that resulted in a total of 17 treatments applied. And you'll see me later on refer to the spot treatments as RX. Okay, and if I'm referring to unthinned, it'll be labeled RX-U. I'll remind you, if I'm referring to RX thin to 800, a spot treatment thin to 800, one of these guys. I'll try to remember likewise for 1200 and 2000. Okay. Yeah, the plots that we treated, the spot treatments or radial treatments, also called spot treatments, were 40. The treatment plot areas are 45 by 45. Okay, the broadcast treatment, the broadcast complete, broadcast woody, etc., were 35 by 35 meters. The reason for the difference in plot sizes was we had 400 stems per hectare in the spot treatment plots, and we had 1,600 stems per hectare in these broadcast treatment plots, and we wanted a two-row untreated buffer around each of the 25-meter by 25-meter measurement plots that was at the center of each of these treatment plots. Okay, the rest of the stuff on this slide is in detail that we won't get bogged down in right now. All right, so what have we found? What have we seen over the 20-year period? So interesting trends in aspen density. Here, the aspen density for the BN, the untreated aspen stand with spruce planted in it. The pure aspen stand tracks much the same. So we started with about 110,000 aspen per hectare in year 1. Okay, the spot treatments reduced that to about half. So somewhere between 35 and 55,000 stems per hectare of aspen early on. And we still had a few sneaky aspens sprouting in the first couple of years after, even in the broadcast complete control. Okay, so that was either the BC or the BW. So there were a few. We eventually got on top of those due to repeated spraying and also manual removal, clipping of any broadleafs, any aspen that popped up in those plots. Yeah, so very rapid, dramatic self-thinning, which is widely observed in aspen over time, so that at age 20, we end up at about 14,000 stems per hectare of aspen, even though we started with 110,000 stems per hectare. It's interesting that although the spot treatments initially reduced aspen density to less than half of what we started with, at the end of age 20, here in the unthinned spot treatments, we're approaching 14,000 stems per hectare at age 20. So it's converging with the completely untreated plot. So it's much less dramatic self-thinning, a much flatter line than is the case for the completely untreated plots. Okay, but they are ending up very similar at age 20. Okay, here on these guys, this is the age 10 thinning, brought the densities down to the targets of 800, 1200, or 2000 stems per hectare. Okay, aspen height. Here I report on the height of the top 400 trees because you can't report on the average when you've done a thinning. I can explain that further later, but just as soon as you start cutting aspen in a thinning, you change the average, right? So depending on whether you remove the smaller trees in thinning, do a thinning from below, or remove larger trees in thinning from above, that makes a difference. So anyway, yes, a trend in height. Aspen grew decently well, not exceptionally well on this site. At age 14, here I show 3 treatments untreated. So the BN, thinning, spot treatment thinning, and spot treatment unthinned. Okay, they're not really different. They're slightly different, but statistically they're the same. at age 20. One thing that did show up was that removing just the understory in an aspen stand did result in an increase in the top height of the aspen. It gave us a 14% bump in the aspen compared to the BN. So it was about 13.4, which puts it, up there somewhere. Right? So removing the understory vegetation did seem to increase aspen height. Okay, aspen diameter at age 20. The untreated, we have had diameters of just over 8 centimeters at age 20. The herbaceous removal, BH, with an intact aspen canopy above, slightly larger, but not significantly larger. Okay, in the BH, spot treatments did increase diameters at age 20 compared to the BH and BN. So that is significantly larger than these guys. Okay, and thinning following spot treatments gave an even bigger increase in the diameter of the top 400 trees. So I'm getting a 30% increase in DBH in this one. We found in this case no differences amongst the 3 densities within the thin treatment. So whether we had 800, 1200, or 2000 aspen per hectare left after PCT, it didn't make a difference on aspen DBH at age 20. So recognize this is 10 years after the thinning had occurred, and we might, if we follow it over time, we might see some differences in future years. So we seem to be seeing some delay. There is a delay in response to the trees. So, at this stage, at age 20, there was no difference in 2 or 4 years of complete control or woody control in the spot treatment. So I've merged those 3, and I've also merged these 3 into a thinned spot treatment. So RX is spot and T is thinned. Okay. Spruce survival. Well, that was a brief look at the aspen responses. Spruce survival was kind of all over the place. So, we expect kind of a general, we expect the numbers. So this is the percent of initial spruce surviving over the first 20 years. So we expect some decline over time because stuff happens, right? So things happen to those trees after they're planted. Okay, but we see pretty good survival early on in the in the 2 spot treatments. Thinned and the unthinned. So the thinned is doing slightly better than the unthinned. Okay, and we see that the unthinned has a steeper decline, particularly after age 10. So we see just that there's a little slight, very barely perceptible bend here, and the angle increases. So mortality is continuing to increase over time in the unthinned spot treatment. Okay, so those 2. The lowest ones are the woody early on. The woody and the complete control show less spruce survival in the first 5 to 7 years than anybody else. But then after age 10, they emerge and come out above the untreated, okay, and the BH, the herbaceous control, understory herbaceous control treatment, which end up having the lowest survival at the end. So what's happening? Okay, so what's happening with the low survival in the woody control? Well, the woody control gave us a field of calamagrostis starting at about year 2 and persisting through until about year 10 as the calamagrostis declined. It did reach its maximum cover at about age 5 and height. So it was close to 1.5 meters in height at age 5 at its peak. Okay, so yeah, so abundant cover of calamagrostis, competing for water and nutrients in in the root zone, so having pretty serious effects on spruce during the first 10 years or so. Okay, broadcast complete. Here we got these nice little spruce out there in the wide open. Clue to what's coming. Okay, so when spruce was 2 years old, over winter of their second year in the ground, we came back in the spring and we found that almost the majority of our trees look like this. Okay, so in the spring of 2005, so. And this injury was predominantly visible in the broadcast complete and broadcast woody control treatments. So these exposed spruce, particularly in the broadcast complete, got their tops fried off. Why was that? We had a thaw in January and February, a couple of freeze cycles in January and February. So one event, it warmed up to about +10. For several days, and then all of a sudden plunged down to -25 for a week or two, and that appeared to be what hammered these guys, caused a lot of injury to foliage and buds. Okay, this got us really upset. Not sure that anybody remembers or was around at the time, but we got a hold of a bunch of seedlings or got the planters and replanted a bunch of trees right next to these guys in the spring in June 2005. Okay, but lo and behold, 3 years later, most of these guys ended up looking like these guys. They're multi-stemmed, often with one good leader, one dominant stem. But they really bushed out. They recovered. So we had buds lower on the stem, sending up new shoots, and the trees recovered. Then subsequently, we ended up pulling out all of the trees that had been planted to replace the dead and dying trees. So we didn't really lose many trees. They just got set back. Yeah, so an interesting outcome, but yeah, and shows how tough spruce is. The other thing that happened in the BN and BH, and so the untreated or the plots with intact aspen canopies, was that at about age 7, we see a dramatic decline in survival as a result of these guys. Three. There. Okay, snowshoe hare. Right. We had an outbreak of snowshoe hare starting in the winter of 2009, and it seemed to persist for a few years actually, and it seemed to come and go after that as well. So they kept browsing. So in the untreated, we had almost all of the trees. So over 96% of the trees had lost their terminal leaders. They lost their tops to browsing. In the untreated and the BH treatment, over 60%. So that grass, for some reason, it was lower, largely because at the time the spruce were a little bit taller. So they were tall enough to escape. The spruce and the BN were small and remained susceptible to browsing, and still were at age 20 because the average height's still only 60 centimeters. Okay, so the end result at age 20 was that the untreated only had 16% of trees surviving. Okay, the broadcast understory herbaceous control had gave us 51% of trees surviving. The spot untreated 67%, and spot thinned, so spot unthinned 67, spot thinned 83, broadcast woody 77, and broadcast complete 75. Okay, so yeah, so an interesting outcome, but we expect some continued mortality in the unthinned spot, probably less in the thin spot. Okay, and we may see an uptick in mortality in the pure conifer stands as a result of competition amongst spruce trees now, as canopy closure is just happening at about age 20. Okay, so the BN is significantly smaller than everybody else and all the other treatments. Okay, BH is bigger than BN, but smaller than the spot unthinned and smaller than all the other guys. Hey, 2-year and 4-year of complete control and the woody control don't differ, so they were pooled into the RX. The 800, 1200, and 2000 thinnings didn't differ, so they're pooled into the thinned. Okay, but unthinned is still significantly lower, still has significantly lower survival than the thinned. Okay, and although slightly lower, the BC and BW don't differ from the radial unthinned or treated. Okay, they're basically they're intermediate between these guys. All right, spruce height. Well, let's look a little bit at spruce growth. So at age 20, spruce are substantially smaller in the BN and BH than in all of the other treatments. Okay, so again, 2 years and 4 years of complete control and woody control didn't differ. So those differences that we saw early on have disappeared. So they were pooled into the RX. Okay, and thinned, the 2000, 1200, and 800 pooled are bigger than the unthinned. So thinning improved. Spruce height at age 20. The BC and BW are taller than the spot unthinned, but they're essentially similar, essentially the same as the RX thin, the spot thinned. Okay, so broadcast complete is pulling out a little bit more, a little bit beyond the broadcast wood, so just slightly better, slightly taller trees. A spruce diameter shows pretty much the same trend as we see for spruce height. So yeah, so don't let people tell you that spruce height doesn't respond. It does over time. It just seems to take a little longer than diameter to show growth responses to treatments. We're seeing pretty much the same pattern in terms of diameter. So the BN and BH, so the untreated and the herbaceous understory control treatment, both with intact aspen canopies, have similar diameters. Part of the reason for this is that there are a fair number of spruce that are smaller than breast height. Right? If we go back here, the average height for these spruces is only 0.6 meters. Okay, so it's lower than breast height. And we're just, the average here is just edging above breast height. So yeah, so a bit of an issue here with sample size, but trees above 1.3 meters, we end up with similar diameters for those two treatments. Spot treatments increase spruce diameter, lead to increased spruce diameters, and that's a significant increase. Okay, thinning again further gives a further significant increase in diameters over not thinning the spot treatments. The woody treatment, broadcast woody treatment, gives very similar diameters. They're statistically the same to the thinned spot treatments, but broadcast complete control is significantly larger than the others. All right, so we'll just look at some pictures. So treatments are increasing diameters. The broadcast complete control is giving us the biggest spruce. But remember that broadcast complete control involved far more aggressive control of vegetation than you probably would ever practice operationally. It was 8 years of repeated herbicide treatments and some hand tending along with that. So here's some pictures of some of the treatments to orient you. So here's the untreated, the BN. planted and untreated. An aspen stand with only a very few spruce left in there. So on average, 16 spruce per hectare. Okay, we don't really see any. They're all, it's like it's a Where's Waldo picture, right? It's very hard to find them. Right? The herbaceous control, where the understory herbaceous was removed, we do see the spruce because there's nothing else in the understory much. A little bit of moss here and there, but yeah, and this hadn't been treated for over 10 years. Just once we got this established, the grass and the herbs didn't come back. The spot treatment, thin to 1,200 stems per hectare. So this was 4 years of spot complete control, thin to 1,200 aspen at age 10. So here's what it looked like at age 20. So the mixture, we can see the spruce quite nicely in these guys. So in the spot thinned, this is the kind of thing that we're seeing. Okay, and a nice mixed understory developing. Okay, a broadcast woody control, a spruce dominated stand. Okay, we do have vegetation, though dominated by Calamagrostis, but there's other stuff that's come in over the 20 years since treatment. Okay, yeah, and here's the broadcast complete control using glyphosate. So a little more crown closure. The branches are starting to overlap here. So in places, once you get into the stand, there's very little understory in here often. We're at the edge to get the picture, but there's a little bit of grass and some other things. Okay, so what are the growth and yield implications? I need to just skip on, otherwise we'll be into the work afternoon with your time. So I used a Mixedwood growth model, MGM 21, to explore the growth and yield outcomes of the different treatments. And here I just show a selection of treatments. So the untreated, okay, here I've got a couple of scenarios. For the untreated, I only did one scenario, no commercial thinning. But scenario B for the spot unthinned was a commercial thinning at about age 40 to 50. Okay. Here a spot thinned to 2000, unthinned or without PCT or without CT. It was a PCT to 2000. Here the spot treatment with after the PCT to 2000 with the thinning, the commercial thinning at age 40. Okay, broadcast woody control and broadcast complete control. So the pure conifer stands are getting MAIs of about 4.7 for the broadcast complete, just over 4 for the broadcast woody. Okay, this one probably represents the outcomes of operational treatments better than this one, right? Because of the repeated herbicide treatments, it's pretty aggressive. So that's probably one of the best ones we could expect for this site. Okay, these other guys, we can see how we grade between deciduous dominance and eventually down to conifer dominance in the BC and BW. So yeah, deciduous shown in green, so just under 5 cubic meters per hectare per year in the untreated, and virtually no spruce yields from that one. The spot treatments increased our spruce yield marginally, still quite small, and we're getting about 4.2 cubic meters per hectare per year of aspen. Okay, adding a commercial thinning to this spot treatment without PCT, increased spruce yields as we released the spruce from the aspen at about age 40. So the spruce, fairly decent stocking of spruce. So we did get a bump in spruce yields and at the same time a reduction in aspen yields. Okay, PCT to 2000 gave us a very slight reduction in aspen yields, very similar to the unthinned. Okay, but a jump in spruce MAI. Okay, adding commercial thinning gave a further jump in spruce MAI. Okay, but a reduction in aspen MAI. Okay, similar totals, just shifting the yields around. Yeah, so spot treatment, PCT and CT increase spruce MAI, but decrease aspen and MAI. So the gist of this is, as we've shown with some of the other mixture studies, is that by selecting different treatments, we can create a range of different outcomes. So you could even dial things in to potentially achieve certain targeted outcomes. So in conclusion, spot treatments alone and in combination with thinning of aspen at age 10 did recreate mixed stands post-harvest. So the pictures show it without all those numbers. So we got mixed stands. Initially, spruce growth was improved by controlling all vegetation versus only controlling the woody, but the differences between the complete and woody control disappeared by age 20. So yeah, so some of my colleagues aren't happy with that outcome, but that's what seems to happen in this aspen-dominated system. And we need to recognize that the Calamagrostis problem on this site wasn't extreme. This is not the ideal environment for Calamagrostis to grow in. The triclopyr treatment gave us more Calamagrostis than we would normally find on most of this site, except in the wet spots. And so initially, spruce growth was improved by 4 years of complete control versus 2. So, about at age 7 and 10, we did see some benefits, but again, that also disappeared by age 20. So aspen was becoming the dominant factor, and the spruce had outgrown the other guys, and the things that kind of worked themselves out. Spot treatments did give smaller spruce than broadcast treatments. So we've got the bigger spruce in the broadcast complete, and the broadcast woody is pretty similar to thin spot treatments. So yeah, so pre-commercial thinning of the aspen increased spruce size over the unthinned spot treatments, but these are still smaller than the broadcast complete. Okay, but they're similar to the broadcast woody. So a note here is I think future measurements would be useful in determining whether the differences in spruce size, or whether there are differences in spruce size amongst the thinning densities between the 800, 1200, and 2000 stems per hectare treatment. So compared to planting and not treating, spot treatments do potentially increase spruce yield. PCT and follow-up CT further have the potential to increase spruce yield. PCT and CT gave shorter rotations, though PCT by itself tended to give slightly longer rotations to get aspen volumes, for aspen volumes to recover from the PCT treatments largely. Yeah, and an option may be we could get better yields by increasing spruce planting density as well with spot treatments. So we could reduce both spot size and the target area that we want to leave as aspen, so that we can get more spruce in there. So by my estimates, we'd get much better spruce yields if we got the spruce planting density up to 600 or 800 stems per hectare in this situation. So we could even plant 1600 and only treat half or 2/3 of the planted spruce. Okay, I'd also like to note that there are other spot treatments that we might try. Imazapyr, our arsenal herbicide, is an excellent pre-planting spot treatment. It's ground applied, soil applied, and has potential in this kind of situation. And I also done one experiment that showed that cutting spots using motor manual methods gives pretty similar responses, and you don't get a whole lot of aspen resprouting if you don't if you leave a lot of area around the treated spots untreated. So it has potential. Gratefully acknowledge support from FRIA, from industry, particularly Blue Ridge Lumber, Canfor, from Dow and Monsanto for work on this site. We had support from the Alberta Herbicide Task Force, Canadian Centers for Ecology, the Alberta Mixed Management Association, West Bogey, yeah, and others, government support and the university support. So thank you. Sorry I've gone overtime, as I have a habit of doing. There's an aerial shot of the study site. So thanks.